Hello everyone, welcome back to the channel. In this project, I will do topic modeling on a series of text documents to classify them into 4 groups. The text documents are individual chapters from 4 novels by Jane Austen. This project is based on an example of topic modeling by Julia Silge and David Robinson. The link to the original project is provided in the description box below. So, without further ado, let's begin. Before we start our coding session, let's briefly discuss what topic modeling actually is. So, topic modeling is one of the techniques under the unsupervised machine learning, where we are going to classify or cluster a series of documents based on topics. And the popular topic modeling method is called the latent Dirichlet allocation, or LDA, where it will use probabilities to classify those documents under the topic. So there will be 2 probabilities we will be looking at later on, which are beta and gamma. For beta, it is a per topic per word probability, or the probability that the word to be classified under that one topic. As for the gamma probability, it is a per document per topic probability, which in other words means that the probability of that document, that one document, to be classified under that one topic. So this is one example of topic modeling. This is a research paper, and it classifies documents, a series of documents, which the source of those documents are Twitter and Reddit. And I'll provide the file for this research paper in the description box below, so you can check it out if you want to find out more about the topic modeling process. As usual, the first step in our project is to load the libraries and packages that we will be using. Mainly there will be 4 in this project, and we will load them using this library command. The first package is called the tidyverse package. If you're familiar with my previous videos, or you're familiar with this art programming language, the tidyverse package contains a series of other packages that are useful when we're playing around with our data. For example, if we want to clean our data, we can use the dplyr package, or if we are working on the data visualization, we can use the ggplot2 package. You can have a look of the list of packages available under the tidyverse library here in the tidyverse website. The second package that we will use is called tidytext. This is for us to do a bit of text mining on our documents. The third package is called TM, also useful when it comes to text mining projects. And the last one is topic models. This topic models package contains the functions that we will use for our topic modeling process. So we will run all of this code to load them in our workspace. So now we are going to upload or load our series of documents into a corpus. And this series of documents, I've placed them inside one folder, which I've called Jane_Austen. And as I mentioned earlier, the documents are individual chapters from 4 Jane Austen novels. The novels are Emma, Lady Susan, Persuasion, and Pride and Prejudice. So this I've these individual chapters, they are put inside a text editor and saved as individual chapters, and I've collected them and put them inside one folder, and we're going to put them into a corpus using this corpus command under the TM package. And we're going to mention the source or the location of the documents that we want to put inside our corpus here, and inside these double quotation marks is the name of the folder containing all those individual chapters, and I will save this inside a variable called docs. If we're going to look at the documents, at each of those documents, we're going to use this command called write lines, and we're going to specify them as character, and we'll have a look at the first document, or the first text document under this Jane Austen folder. So we'll run these two lines of codes, and here, as you can see, this is, if you're familiar with the novel, you can see that this is actually the first chapter for the novel Emma. See here, it has the name of Emma Woodhouse. So the first chapter of the first novel is the first novel in this folder, in this Jane Austen folder here, is Emma, and this is the first chapter. If you're familiar with text mining, the text mining process, obviously the next step is to pre-process the words, where we're going to clean the words, so before we can do analysis on them. So the common commands or the common processes, this pre-processing step include stripping off any extra white space between the text or between the strings or the characters, and we're going to use this. We're going to use the tm_map function here. So if I'm not mistaken, this tm_map is a function under the, yes, it is under the tm package. The first argument is docs, meaning the corpus that we're going to work on, and the second argument is the function that or the pre-processing step that we're going to apply on the strings or the words inside this docs corpus here. So for the first one, we're going to, like I mentioned, we're going to strip off any extra white space, and the function is strip white space, strip extra white space, and we're going to save this back inside the corpus. The next pre-processing step is to transform every word inside the text documents into lower space, and for this we're going to use a function called content transformer, where we'll apply the toLower function on the corpus. Again, save this back inside our corpus. Next is to remove any numbers. We're not actually going to look at numbers in our text mining process here, so of course we're going to remove them. Once again, save them inside our corpus. And we're also going to remove punctuations. And lastly, the most important thing when it comes to text mining is to remove stop words. Stop words, if you're unfamiliar with what they are actually just common words that are used in this case in the English language. Words such as articles, and the, and in some cases we perhaps want to remove any titles that we give to people, such as Mr. or Mrs. Maybe we the in the Jane Austen novels, we're familiar with the characters referring to others with, like such, for example, Miss Woodhouse or Mr. Knightley. We're going to remove those titles as well. And to do that, again, we'll use this tmap function on our docs corpus, and we'll use this function called remove words. And we're going to remove the stop words in the English language. Save this back inside our corpus. And now we're going to run these 5 lines of code to pre-process our corpus right here. It will take some time, because usually it will take a long time, because it actually based on your the memory size of your laptop, or also the size of your corpus. If you have a lot of documents inside this corpus right here, it will take a long time, but this takes less than 10 seconds to finish, so that will be fine. This is fine. Now that we have pre-processed the words, we're going to put them inside a document term matrix, where the number of times that a specific word appear in those series of documents in our corpus, this matrix will count how many of those words appear, and they will classify them into terms. So here is create document term matrix. We'll use this function document term matrix of docs, and we'll save this inside a variable called dtm. If we want to have a look at the first, let's say the first 10 terms inside our document term matrix here, we're going to use this inspect function, and we'll specify the matrix that we will be using, dtm here, and we're going to look at the first 10 terms from the first document. So the first document 1, separated by a comma here, where we're going to see the first 10 terms. As you can see, in the first chapter of Emma, we see the terms able appears twice, abscess appears once, acceptable appears twice, and so on. These are actually 10 terms that appear in this text document here. Now that we have put them inside this document term matrix, we can now perform the LDA, or the topic modeling process. LDA is, if you recall, is the latent Dirichlet allocation, the method that we will be using to classify our text documents here. Before we continue, I forgot to explain a bit about this project. So like I said, this is based on a similar project from the original source that I use for text mining infos, or the subject on text mining, by the 2 authors on their website. And in their example for topic modeling, they create a scenario where there is like a weird robber entering your home, breaking into your home, and for some weird reason this robber decides to tear apart your books And then when you find them, when you find those books to be scattered around, you don't know which the the pages that have been torn up, you didn't know they come from which books or which novels. So we're going to in that example, they're going to use topic modeling to classify them, to identify. So basically, to identify which novel those pages belong to. So in this case, let's say that a similar thing happened to, let's say in my house, I have these 4 novels by Jane Austen, and then this one weird random person broke into my house and decided to tear apart these 4 novels. And let's just say that I'm not familiar with those novels. I have never read them, and I didn't know like the full story of those novels, but at least I can identify the main characters of those 4 novels. So in this case, I can use topic modeling to identify the pages that have been torn up belongs to which novel. So like I said, the 4 novels that we're using in this project are from Emma, Lady Susan, Persuasion, and Pride and Prejudice. So I'm familiar with the names of characters that appear in those 4 novels. So if we're using this topic modeling, we can definitely, I think that we can see the names of those characters to appear in our analysis, and therefore I can identify which novel they belong into. So for example, in Emma, some of the characters that I'm familiar with are obviously the main character herself, Emma Woodhouse, and her love interest, Mr. Knightley. For Lady Susan, we can perhaps identify by the names of such as the titular character herself, Lady Susan. For Persuasion, I know that the main characters are called Anne Elliot and Captain Wentworth, if I'm not mistaken. And lastly is Pride and Prejudice. The characters are Elizabeth Bennet and Mr. Darcy. So based on the names of those characters, I can guess that in our analysis, in our topic model analysis later, we can see that the probability of the names of those characters to appear in each topic can help us identify the novels that we are going to to group together. Okay, so now let's continue with our analysis, our topic modeling analysis. And here we are going to perform the LDA method, and we're going to classify them into 4 topics, which is the 4 Jane Austen novels that we have in our document right here. For this, we'll use the LDA function on our document term matrix. K here specifies the number of topics that we want to group the documents into. And to ensure that we're going to have a reproducible results, we're going to set the seed here as 1, 2, 3. For this, I'm going to save them inside a variable called dtm.lda right here and run this code. It will take some time to run this because it's trying to classify them into the 4 topics. So I've skipped ahead since the process of running this line of code right here takes some time, so I've skipped ahead. And if we're trying to have a look at our LDA, the result of this line of code here, you see that it's just a sentence saying that LDA underscore VAM topic model here with 4 topics. So if you recall earlier from the slide that I've shown, one of the probabilities that we're looking for is the per topic per word probabilities, which is called the beta probability in this topic modeling process. And we're going to extract them using a using this function from the tidy text package called tidy from dtm.lda here, and we're going to look. We're going to an easier version of saying this is we're going to tidy them up, clean them up, and arrange them in terms of the beta probability. And let's save this inside a variable called dtm topics and try to have a look at the first few rows, at the first 10 rows of this dtm topics variable here. So as you can see, we'll look at this term. The term able here, the probability that it will appear under the first topic is 0.0009. The word able has a probability of 0.00088 to appear under the second topic, and you can see the rest for the other terms here as well. So like I said, the beta probability here stands for the probability that this term, in this case able, to appear in the first topic. So obviously there are a lot of terms inside our corpus right here, so we're going to extract only the 10 terms that are most common within each topic. For this, we will use this dtm.topics table. This is actually a table. It's a table. It's like a table, but here it is called a table. And we're going to use a pipe operator under the dplyr package, and we're going to group them by topic, and we're going to select the highest probabilities, the highest beta probabilities. We're going to select the top 10 most popular the most common terms based on the beta probability value. And we'll arrange them in descending order right here. So this table, which is the result of this line of code that we just ran earlier, it says here that the term Emma has the highest beta probability to appear in the first topic. So I think that we can already tell that the first topic, or the first novel, we'll consider topic here as novels in this case, in our project right here. So the first novel is obviously going to be Emma, because the name Emma appears at the top of this beta probability. And there's also this name of Weston right here, which is the name of another character inside in the novel Emma. Since in table here, a table, they only like in this case, when we run this line of code right here, the display, the output that we get lists only the top 10 terms that are very common to appear in the first topic. So basically the output here shows only the terms, the most common terms that appear in the first topic, and here we can, like I said, we can already tell that it's from the novel Emma. If we want to have a look at the other topics as well, we can simply just run an extra command, an extra function to this line of code. But I think it is better if we try to plot them, so we can see clearly all 4 topics or all 4 novels in just one window. And first, what we're going to do is we're going to save the output, this table right here, this top 10 common terms table here inside a variable which we will call top terms. And then we're going to plot them using the functions under the ggplot2 package. So the first we're going to specify the data that we will be visualizing here, which is top terms. And first let's add a new column in our data here. We'll call it term. Not really adding a new column, but we're going to we're going to reorder the terms, this term column here, based on beta instead of topic. As you can see in this, the output for our command here, if we type in top terms here, this will be the output. So you see that they are being ordered based on the topic, meaning this is the first topic. But we're going to reorder them in terms of beta, the beta probability here. Now we're going to plot them using this ggplot command, where x is term, and on the y-axis is the beta probability, and we're going to color them based on topic. So the bars inside each in each topic the bars will be colored based on the topic itself. There will be 4 colors in our data visualization here. We're going to use this geom call layer, and we're going to hide the legend. We're going to separate the bars based on topic, and flip the coordinates. And lastly, one of the things that I prefer to do when it comes to data visualization is to add labels on the bars itself. So in this case, I want to put in the beta values here, rounded up into 4 decimal places, adjusting them to be this hjust function argument here is so that we can adjust the location of those text that appear on the bars. So we'll run this and zoom in on our plot. So here we see that the terms in each topic, in this first topic, and also the terms here, and the beta probabilities. So in the first topic, as we have seen earlier, contains here the name Emma and Weston. So they are characters from the novel Emma. This second topic right here has names that everyone is familiar with: Elizabeth, Darcy, and Bennett and Bingley. So obviously the documents classified under the second topic here are chapters from Pride and Prejudice. So honestly, I'm not actually familiar with the novel Lady Susan itself, so I'm not sure. I wasn't exactly sure yet on what the third topic is about, but when I look at the fourth topic here, I see the name of Anne, Captain, Elliot, and Wentworth. So as I mentioned, the names of the main characters in the novel Persuasion are called Anne Elliot and her love interest, her love interest, Captain Wentworth. So since the fourth topic is obviously from the novel Persuasion, so that makes the third topic to be documents or chapters from the novel Lady Susan. And as you can see, there is the term lady here. So basically, this is the end of this project. If you have any questions or there are parts that you don't understand, feel free to drop them in the comment section below. If you enjoyed this video or you might have learned something new from this, please give this video a thumbs up and subscribe to my channel for more contents like this in the future. Thanks for watching!